Sunlight is now officially liquid fuel. This isn't about solar panels powering a grid. This is about a device that could slash your cost of driving to nearly zero. Scientists just hit a stunning 31.3% efficiency record, turning sunlight and water directly into hydrogen fuel, completely bypassing the biggest cost of clean energy. But how they did it combined space-grade tech with a trick borrowed from a simple leaf, and it changes the game entirely.
For decades, green hydrogen has been the ultimate promise of clean energy, a fuel you can make from water that emits only water when used. The problem? Making it has been clumsy and expensive. You start with a solar panel, around 22% efficient. You convert that electricity, losing some. You transport it to an electrolyzer, losing more. And then the electrolyzer splits water, with its own inefficiencies. By the end, you've lost a massive chunk of your initial solar energy. It's like collecting rainfall with a bucket full of holes. This multi-step process is why green hydrogen can cost up to 5 times more than hydrogen made from natural gas. It's been the single biggest barrier to a hydrogen economy. So, how do you fix it? You don't. You throw out the rule book.
Instead of separate panels and factories, a joint team of researchers at Switzerland's EPFL and the U.S. National Renewable Energy Laboratory, or NREL, asked a different question. What if we could do it all in one step? They created what's called a photoelectrochemical cell, or PEC. Think of it less like a solar panel and more like an artificial leaf. It's a single wafer-thin device that absorbs sunlight and uses that energy instantly to split water molecules on its surface. No electricity grid, no transport loss, just sunlight and water in and pure hydrogen out. To smash the old records, they fused 2 powerful technologies. First, they used a multi-junction solar cell. Unlike the silicon in your rooftop panels, these are stacked layers of exotic materials. The same kind of 3-5 semiconductors used to power Mars rovers and satellites, which can capture a much wider spectrum of sunlight. Then, they bonded this supercell directly to a new generation of catalysts, the materials that actually perform the water-splitting chemistry. The result? A staggering 31.3% of solar energy converted directly into hydrogen. That's not just a record, it's a number that fundamentally changes the economics of clean fuel. But there's a catch.
That space-grade solar cell uses materials like gallium arsenide, and the most efficient catalysts often use precious metals like platinum. Right now, this device is a masterpiece of engineering, but it's too expensive for mass production. So is this just another lab curiosity? No, and here's why. This 31.3% record is the proof of concept. It proves that direct solar hydrogen production at this efficiency is physically possible. It provides the blueprint. The next wave of research, which is already underway, is focused on swapping out those expensive ingredients for cheap, Earth-abundant materials, replacing gallium with silicon and platinum with catalysts made of iron and nickel. The goal is no longer to prove it can be done, but to prove it can be done cheaply. And that's when it arrives in your life. What does a world with cheap, direct solar hydrogen look like? It means hydrogen fueling stations could generate their own fuel on site with just an array of these solar leaves and a water hookup. For transportation, it's a game changer. Imagine a hydrogen car you can refuel in 5 minutes that has a longer range than a comparable EV and whose performance doesn't degrade in the winter. This technology directly challenges the battery's dominance. But it goes far beyond cars. It means long-duration energy storage for our power grid, storing summer sun as hydrogen to be used in the dead of winter, something batteries can't do for more than a few hours. It means decarbonizing the backbone of our economy, the heavy industry, steel production, and transoceanic shipping that batteries are simply not suited for. This isn't just a new way to power a car, it's a new foundation for our entire energy infrastructure. So here's the question. If refueling was as fast as gasoline, and the fuel was made cleanly from the sun, would you choose a hydrogen car over a battery electric one? Let us know your thoughts in the comments. This breakthrough means that a single device turning sunlight and water into fuel is no longer science fiction. With the 31.3% efficiency barrier now broken, the roadmap to cheap, abundant green hydrogen is finally here. If you want to understand the technologies that are actively shaping your future, make sure to subscribe to Decoded Future. In our next report, we're diving into the world of solid-state batteries and why they might make it possible to charge your EV in under 10 minutes. The future, arriving sooner than you think. The future, decoded.